Okay. All right. So today we're gonna do a few notes, and then I want to make sure that we get a little hands-on where we can try some stuff out. I want to start with the problem we left off on yesterday, and it will do a kind of a nice tie-in today with what we need to talk about. Hopefully this makes sense to you as we go. Seems like you guys had a pretty good handle on this. You do need a calculator today. I'm missing quite a few. Science borrowed it from me today, and they haven't brought them back. So at some point I won't have any. Let's talk about the section we're in. We're in section 4.2 to 4.3. Okay, this is the section that we're in. Okay, these two particular sections, we're talking about the trig functions, the trigonometric functions. Now there were 6 main types. There are 6 functions altogether. Okay, 3 of the main ones. 3 are reciprocals. The main functions we have, okay, as of this moment, the 3 main ones: sine, cosine, and tangent. These are the ones we focused on yesterday, okay, which is great. These are the main ones that your calculators have. All scientific calculators have these. I need to make sure that we know them, okay? The abbreviations are what you see in your calculator screen. So sin, cos, and tan. But again, sine, cosine, tan. That's what I always call them. Okay? Those are the main ones. Now again, what we'll talk about today is once we have, those particular functions, we'll talk about, how you can type them in your calculator, and we'll talk about all that good stuff today. And eventually we'll mold into that tomorrow. Okay? The next ones, the reciprocal functions. These are the ones we have to talk about, and that's why I'm going to do a little bit of integration with these today. We're talking about cosecant, secant, and cotangent. Now, the reason I wrote them in this particular order is that they match perfectly one-to-one with the ones above it. What I mean by that is that sine is automatically paired with cosecant. They're reciprocals of each other. Okay? These are the reciprocal functions. Reciprocal means you flip them over. We're going to talk about that today. But again, how I know which ones are paired together for the reciprocals? Every pair, one of them starts with the letter C. Every single one. Every single pair of reciprocals. Okay? So for instance, sine is paired with one that starts with the letter C. Cosine and secant, one of them had the letter C in it. Tangent, cotangent, one of them had the letter C as the first letter. They're always paired like that. Question?
Can I put my water bottle?
Wait till later. Okay.
I'm dehydrated.
You'll be fine. You're not passing out.
Why is it just secant and then they just add a code to it?
What?
It's secant and then they just add a code to it.
So is sine.
Yeah, sine and cosine.
And tangent. Why did they do that?
Just the way they pair. So, all right. But anyways, the actual abbreviations here:
What did they do?
CSC, SEC, and COT. Okay, these are the abbreviations. Now the problem is, and this is a question I had yesterday. I think it was like 4th period yesterday. They asked about the sine function in general. The sine function, if you don't know, this is how it's written. This is the formula for it: opposite over hypotenuse, right? And how I remember that, like how do I know what the formula is? It's SOHCAHTOA. That's how I remember it. And again, I know my penmanship isn't the best, but so means opposite over hypotenuse. The capital letters are the trig functions. The lowercase letters are the actual fraction that goes behind it. So sine of an angle, whatever angle you're going to type here, you use the opposite wall of that right triangle for where that angle sits, and then you divide by the hypotenuse wall. Well, the reason I bring this up is because I want to talk about the reciprocal function. Some people had a misconception. Some people thought that when I type in sine of -1, you get the same thing as cosecant. That is not the case. They are not the same button. Okay. In fact, most scientific calculators do not have a cosecant button. They just don't. They don't have it. Graphing calculators. Where's my text? Where's that big one I have? That one has it. Yeah. This has it. It's pre-programmed in the menu though. I have to go find it. It's not just necessarily a button on the actual screen itself. You have to go like in the menus, go find it. But everyone has this button. This one we're going to look at possibly tomorrow. We're going to look at what this means, how do you use it. I think most people have it. Once you've seen it in Algebra 2, you probably know what it means. But it's an inverse function. It's not a reciprocal function. It's a difference. So we'll talk about that we'll talk about this tomorrow. But this one is the one I want to bring up today. Like, what is it? Like, why would anyone choose this when you don't even have the button on your screen? And that's what I want to talk about today, okay? And I want to do that one problem I gave you right at the end of class yesterday. It was the one with the mountain problem. And we were doing the ski slope where you had the rope, the cable coming down. I want to talk about that problem. Now, I don't remember the numbers I used for you, so I'm going to kind of make it up. Let's see if this is about the same numbers. So we had a mountain. And the mountain, I think we said it was like 6,200 feet. Or something like that. And then the cable is going to the ground. And here's the part I don't remember. I don't remember the angle. I don't know if it was like 20 degrees.
30. Was it 20 or 30?
It was
20? 20?
It was 30.
It was
25. It was 30.
It was 30.
It was
35.
30?
30.
25. 25.
30.
It was 30.
We're on 25. We're on
Let's
the
see
split
what does
difference.
it really matter.
Alright,
No, it matters.
alright. We're going 25. Alright, now.
20.
What we talked about yesterday was, how to set this problem up. So it is a right triangle. Okay, so it is a right triangle, so here it is. So we have the right triangle, and we set this up by using the sine function. How I know? Because my goal was to find the length of the cable. And when you have a right triangle, when you want to like set up in your formula like which one of the three you should pick, you have to label the picture. And that was one of the questions I had yesterday. That how do you know which one of the three? Well, when you have your angle, this is theta, you label all the walls that you need. So like this is the opposite wall because it has a number there. This is the hypotenuse, and that's what I'm looking for. And it looks like on this picture, I don't need the adjacent. The adjacent wall is the wall that's always next to your angle. I don't need it in this case. There's no number there, they're not even asking for it. So I don't need it. Now, here's the goofy part. On a right triangle, the opposite and adjacent could flip-flop. They're the only two words that could flip-flop because it matters where your angle is at. If my angle is up here, if my angle was up in the air, maybe I was at the top of the ski slope and I was looking down, it's called an angle of depression. If I was up here, this would be the adjacent wall. It's the wall next to it. This would be the opposite wall, the wall across. So it does matter where your angle's at. So since I'm doing an angle of elevation looking up in the air, you do have to use an angle of elevation, and I have to use the opposite wall. So what we talked about, okay? We talked about the sine of this angle, so sine of 25, or something close to that, equals the opposite wall, which is the 6,200 feet, over x, because that's the hypotenuse wall, because it's opposite over height. And what we talked about yesterday was how to solve that. We flip the two numbers around. So this was the shortcut that we did a little flip by moving the x to the other side, and you switched it with the sine of 25. Now the reason why you do that, we have to get the x off the bottom, so you are multiplying it across. And since this is a number, it'd be a number times x, you just divide by it. So that's why they flip-flop. Now, the reason why I said that this is difficult is that some calculators literally can't do that. You can't even type that in. In fact, it's these little basic scientific calculators, the ones that look like, let's see, do I have an example of it?
I get what you're talking about.
These. It's not menu driven. You have to, you literally can't type that in. You actually have to find the sine of 25 first, write down the decimal, and then take 6,200 divided by that number. Okay? Now, on everybody else's calculator, it's called a menu driven calculator. You can actually just type in exactly how you see it and hit enter. Okay, but there was a reason why I said the reciprocal functions yesterday. This problem is a perfect candidate for a reciprocal. The reason being, now I know some people are like, well, Ward, why do you even do that? We don't even have the buttons. But most people do have Chromebooks. That's probably the most common type of calculator you probably have at home is a computer. You could just type in, into Google search the actual problem you're doing and it'll just spit out the answer, which is kind of nice. Google can work as a calculator and you can just type in the exact numbers. So if you were unfortunate, you forgot your calculator at home, or you forgot it, at school, and you're trying to do homework at home, and you're trying to figure out these numbers, you can just type it in Google, and this is where the reciprocals would actually be a better choice. It would actually be easier to type into Google with the reciprocal, because I would actually do the cosecant, because the cosecant of my angle is just the same as sine, I just flip it over. That's all it is. It's just the same fraction, they just flip the fraction over. So when I actually write it down, cosecant of 25 degrees, it's just this. And now you can see why this would actually be a more useful formula, because on Google, all you'd have to do is type this by multiplying that over. You don't have to do the whole switcheroo thing where it's 2 steps, especially on like a scientific calculator. I can just multiply the 6,200 feet over, and you could just type this into Google and hit enter, and it would actually tell you your number. Okay, now, does everyone have a calculator out in front of you?
Or-
Okay, here's what I want you to do. Make sure you turn on your actual calculator. I need to make sure that on the screen somewhere there is a little lowercase d or a DEG somewhere on the screen.
Yes.
Why?
That's why I was actually really walking around yesterday. There's 2-prong attack. I had to check, I had to film, but I also had to check, is your calculator pre-programmed into degree mode? Because if it's in rad, radians, you would actually get different answers. And that's why I was kind of walking around to see, was your answers, did they make sense? They have to have a DEG somewhere on the screen, or a little lowercase d in a box. I think it'd be like, yours would probably just have the D, probably
I
on
have a DEG.
Okay, oh, you have a DEG. I didn't know what that one would have. Text and instrument, this is yours.
Yes.
They usually have a DEG. Casio's, does that just have a D on the screen?
It has an uppercase D in the corner.
That's it, so it's degree mode. I don't even know how to switch that one. There's a menu where you can flip it.
How do you switch it?
On the Texas Instrument ones,
Where's
there's
that reset?
there's a DRG button.
What's reset do?
Resets just wipes the memory real quick. It's a quick way to get things off the screen when it has a bunch of stuff programmed. It's like when you accidentally switch to science mode and you want to get rid of it, you can just reset it real quick. Alright.
It's just 0.
What does GRAD mean?
What's graph?
Gradients. This is just a different form of measurement for angles.
Is it like radians?
It's gradient.
I like radians.
It's slightly off.
Whoa.
Alright. Okay. Real quick today, I want to do a couple examples where we actually discuss how to find numbers and actually do one by yourself. So let's actually do a problem here where we actually try to find the height of an object. Okay? Hopefully this makes sense. Alright, so here's what I like to do. On your paper, I would like you to draw a problem where there is a building. Okay? So draw just some rough building that you have here, okay? Alright, so here's my building. Alright. And against the building itself, we have a ladder. So you want to draw a ladder going up to the top of the building. Okay, now on the ladder itself, let's say that's a 50-foot ladder, because ladders come in increments of 50. And let's say the ladder itself was at an angle of, let's say, 31 degrees with the building. 31 degrees.
Does the ladder have to be 50 feet tall?
We're saying it's a 50-foot ladder. It's going all the way to the top. Okay. All right. Here's the question. How tall is the building?
27 feet.
So let's figure it out. So I want to see you try to figure out the numbers on your screen on your screens on your calculators. I also want you to write down your formula. I want to see if we can set this up correctly. Okay. This one I'm not going to walk around the room and check. I just want to see. I'm going to give you a little bit of time. See if you can figure out without me telling you what is the right formula to pick. What's the number we're getting, and does the number make sense? And then we're going to try a problem on our own in a little bit. So, I'll show you what I mean by on our own here in a second. Because we're gonna go through this one together here. Remember, the trick is what I would do is label your triangle. Like label where the hypotenuse is, label the opposite, label the adjacent. So that kind of narrows down which formula you're going to pick. And then see if you can solve for x. And then we're going to do a little bit of checking here.
I wonder if I got this right. Maybe you probably.
Okay? I want to at least give you time to try it without me just telling you the answer right away.
Can
See
you
if
come
you
up here
can
and
figure
tell me if I'm close?
I did it.
it. Did it?
Jerry, what'd you get? 25.75. What's the last?
If was he right?
25.6.
Oh.
What'd you get?
No?
I'm not saying it's right.
What'd you get?
Sine 31 times 50.
That means I'm wrong.
You
Are
are.
you sure?
Well, if they got theirs,
Oh, I
if they
think
got theirs right.
What'd you get?
I didn't get 25.
What was your trig function you picked?
Code.
Sid.
Oh, I'm wrong, aren't I?
50 cents.
You do opposite.
What?
Oh, why did I get 50?
Right.
That's what I'm
Go to the meeting.
I was doing the other angle.
Yeah.
Don't worry.
Oh.
You suck.
Yeah, I'm gonna be trying to sort them all, man.
That's what I heard.
I ran a 7-minute 45-second mile the other
Did
day.
you really?
Yeah.
I
Swear to God.
was underage. I was
Under 8, I've been running like 4 miles a day.
40.
I know.
Great.
I wanna die.
Alright,
Yeah,
okay, hey. Alright, I need somebody to help me out with the labels. Not the answer, the labels. So Tyler, I saw your hand go up.
What?
I just want to label the triangle. What is theta?
31.
Shh. Hey, so theta is 31. Now, where are the other walls? What do we have labeled?
X is the opposite wall,
Okay, that's the opposite wall.
and 50 is the hypotenuse.
Hypotenuse. Alright, so now, before you move on, by just labeling the picture, the hypotenuse should always be the wall that you know instantly. The reason why the hypotenuse is always the one wall that does not touch the 90-degree marker.
Yes.
Okay? Make sense?
Yes.
Okay, now that we have that labeled, it automatically tells me this had to be the formula.
Whoa.
Okay? Now the reason why this is the formula is because it's the only one that uses O and H. That's because when you look at the formulas, it's sine is opposite in hypotenuse, cosine is adjacent in hypotenuse, so that's AH, and the last one is O and A. Well, on this picture, I'm just using opposite in hypotenuse, so I'm doing the sine of my angle, so sine of 31 is the opposite over the hypotenuse. Now, the last step here, multiply the 50 across to get to 50 sine 31. And you get to your number, and I think most people were getting 25 points.
Step 5.
Okay, and now what's the label?
Feet.
Feet. All right, now.
Food.
Okay. Now the one thing I was asking for, did that number make sense?
Yes.
7.5. All right, hold on. 7.5. Now, let's talk about this. I agree. That does make sense. The reason why it makes sense, that was a really small angle. That means that has to be a really small side.
Why?
Okay, the smaller the angle, the smaller the wall across from it. Okay, so now, Morgan, I want to know, no, you're not wrong. What was the number you came up with, Morgan?
48.
That's the bottom number. That's the number that's down here. Okay, now, the reason being, why this is 48, or really close to it, because she used cosine. Cosine is when you're using this angle, she used the 31, she did cosine, she's finding the adjacent wall. And so her 48 number was the bottom wall, and that makes sense because, John, what was the angle on the top of your picture?
59.
59. Okay, this was 59, and it should give you a number like 48 in that ballpark. Okay, it should have been something very close to that. So her number, if you just thought about the wall having 31 degrees and getting 48, that number didn't make sense because that angle is really, really small compared to 90 degrees. Opposite of 90 is 50. That should be the biggest wall, and they're almost proportional to each other. So having a wall across from 31 being 48, the numbers are too close. So that was just something that I wanted to make sure of. Okay. Okay. Questions, comments.
This is real.
You didn't get 48, you got 42.
It's 42.
I was just.
Okay. It gave me the bulk.
Why is nice?
All right.
Just because I'm word favorite does not mean you can be mean.
All right. Hey.
That's an opinion.
Do we feel comfortable?
Trust me.
Yes!
Last problem of the day.
Fake news.
Last problem of the day. Here we go.
Trust me, if you could say
I'm not trusting you, you're fake news.
or aren't I your favorite?
Okay. Last problem.
Fake news.
Yeah.
Okay. Here's what I'd like you to do. On your paper, and this is where you get freedom of choice. On your paper, I would like you to draw some ground here and draw a water tower. I don't know how you want to draw your water tower. Here's your one. All right. Now,
Which one?
it doesn't matter. So you're drawing a water tower. Okay. Now that you have your water tower drawn, the goal here is to find the height of it. We don't have that. We're going to find the height of your water tower. Here's what you get to fill in. You get to put how far away you are standing. You get to fill in this number right here. Don't say it out loud. You can put it in any label you want. You do have to label it. And your angle to the top. You can fill this angle in with whatever you want. You cannot fill in 45 degrees.
Darn.
Because if it's 45 degrees, the distance you're away from the object is the same as the distance going up the object. So you can't pick 45 degrees.
It has to be less than 90.
It can be any angle less than 90, not 45.
What about 89?
Okay, I had somebody pick 89. So they picked 89.99 or something like that. That's fine. You can pick any angle you want, not 45. Okay? So you're gonna put that's your angle of elevation to the top of the water tower. And you can pick the distance from the water tower, but you have to label it. But you cannot pick 45 degrees. Okay? As you're setting this up, I'm gonna walk around the room. I wanna see the numbers you chose, the number you came up with, and how did you type it in your calculator.
Wait, we need to figure out
Okay.
degree, or.
Yep, you have to figure out the height of the water tower, because you don't have that number. Okay? Okay, so I want to see it. I want to walk around the room. In fact, I'm going to have Morgan videotape some people. She'll ask you a couple of questions. So,
I'm not answering them.
so I'll give you a couple more minutes. In fact, when you get done, I'll have Morgan go to you first, and she'll interview you to see what your numbers are. Morgan, just try to make sure when you're videotaping, get really square on the paper and all the other good stuff.
Hey Dakota.
Hey.
Show me what you did.
Angle is 44. This is 55, and I had to figure out this. So this is the adjacent wall. This is the opposite. Oh, shoot, I used the wrong one. I used the wrong. Yeah, I did.
You're trying to find X.
Yeah, I used code.
Oh yeah, it's
I'll
Cam.
be back.
Okay, I'll be back. Are you done, Charisse? Hi, Charisse. Okay, how did you do this?
I picked 50 feet and 17 degrees, and then I did this, and I typed it in like this, and then I pressed.
Good job, Charisse.
Thanks.
Okay, Jared. Hi, Jared. How was your game last night?
It's great.
That's good. Okay.
So
Show me what you did on your paper first.
I put 3 degrees, and I'm standing 150 feet away.
Oh.
So I
Let me
go
see yours. Okay.
3 10 times 150.
Wow.
Good
7.86.
job. Good job. Good game.
Thank you.
John! What a great manager you are.
Oh yeah, thank you.
Okay. Tell me what you did.
I used the top angle, and then since I used the top angle, I did opposite over adjacent. So I would use TOA and SOHCAHTOA. So that would have been tan 49.9 equals 1 over x. Then you flip the tan 49 and the x, and you switch your spots. The x equals tan 49.9 over 1, which equles 0.84.
Great job.
44 is my degree, 50 is adjacent, x is my opposite. So I had to do 50, tan, I had to divide it,
3 degree angle.
Brown's doing
It's
it?
like 50 feet.
and then 44, 51.78.
Good job. Have fun taking your FFA picture. Tyler.
Did your number now make sense?
Show me what you did.
So I'm 726,231 feet away
Yep.
and an 89-degree angle. And so my water tower is 12,676.4 feet tall.
That's a tall water tower.
Yeah.
Mara, great game last night.
Thanks.
What did you do?
I picked 53 degrees and stood 68 feet away, and my water tower was 90.24 feet tall.
Great job. Jaden! How's it going?
Oh,
Jaden
good.
does not like being videotaped.
No, I don't. Okay, so I was 512 feet away, and I picked a 21-degree angle, so I got 196 feet tall.
That is some great handwriting.
Thank you.
Sydney.
Okay, I was 59 feet away, and my angle was 26, and my tower is 28 feet tall.
That is not like 25 feet tall whatsoever.
28 feet tall!
That's what I meant. That's like a 2-inch water tower.
They had to be close, because just your angle, 44 and 46. Alright.
Hello!
Anyway, great game last night. Wake up away.
Yep.
Okay, where's yours?
I did 7,777 feet, and then 44 for my degree. Multiplied it over, and I got a grand total of 7,510 feet.
Great job.
Talk about that number. Why
Talk
that number?
Why that number?
It makes sense because it is less than that one, because that one is 46 degrees and that one's 44 degrees.
Great
So my answer
job. Hey, how's it going?
Pretty good.
Good.
I chose 200 feet away with 75 degree angle, and I got 746 feet tall.
Good job. Way to get it. Bye.